In this video, we will be talking about delocalization. To start, we have aromatic compounds and we have anti-aromatic compounds. In order for a compound to be aromatic, it has to be cyclic and planar. It also must have uninterrupted pi bonds. And it must have 4n plus 2 pi electrons, where n is an integer. So you could have 2, 6, 10, 14 pi electrons. For anti-aromatic compounds, they are also cyclic and planar and must have uninterrupted pi bonds. And they have 4n pi electrons. So that means they either have 4, 8, 12, 16, 20 pi electrons. The first question asks, are these compounds aromatic, anti-aromatic, or neither? For the first compound, we have 3 double bonds and a positive charge here. So that means we have 6 pi electrons. The compound is cyclic and planar, and there is uninterrupted pi bonds, because if you draw resonance forms, this positive charge is able to move on every carbon. So eventually, those pi bonds are going to be filled or uninterrupted at one point with the resonance forms. So this compound would be aromatic. For the next one, we have 2 double bonds and we have a lone pair. So this compound is going to have 2, 4, 6 pi electrons, because this lone pair is going to exist in the p orbitals. So that means this will have uninterrupted pi bonds, so this will be aromatic. For the next one, we have 1, 2, 3, 4 double bonds, and we have an NH group. So if we draw our missing electrons, these electrons here are not going to be in p orbitals. However, these electrons will. That means we have 2, 4, 6, 8, 10 pi electrons, which fits the criteria for aromaticity. They are uninterrupted, and the compound is cyclic and planar. That means this compound would be aromatic. These electrons do not exist in p orbitals because there is already a double bond filling the p orbitals here. For the next one, we have 3 double bonds with an oxygen with a positive charge with a lone pair of electrons. So the compound is cyclic and planar. There is uninterrupted pi bonds, and there is 6 pi electrons. These electrons are not pi electrons. They're outside of the ring. This compound is aromatic. For the last one, we have 2 negatively charged carbons with a double bond. These electrons are going to be pi electrons. They're going to exist in the p orbitals, and so this compound is cyclic planar. It has 6 pi electrons, and they are uninterrupted. So this compound is also aromatic. The big trick between an aromatic and anti-aromatic compound is how many pi electrons you have. Moving on, the next question asks us to draw resonance forms. For this compound here, I'm going to start at the double bond and move that to the oxygen. And then I can take the lone pair from the nitrogen and make a double bond. If I draw that, that is one form. Notice how I started with a neutral molecule, and this molecule is also going to be neutral because the positive and negative cancel each other out. So another resonance form would be doing the same thing, moving that double bond to that oxygen, and then taking one of these electrons from the oxygen over here. Those would be valid resonance forms. For the last question, we have a negative and a positive charge here on the nitrogens. So with this negative charge, I can make a triple bond and make the double bond into a single bond. However, this carbon here has a negative charge, which is going to be fairly unstable. In order to fix this, we are going to take these electrons and make a double bond and move those electrons onto that oxygen. Since these are electronegative atoms, they don't mind taking extra electrons. However, carbon is not very electronegative, so it doesn't like those extra electrons. Notice in each form, we have a positive and a negative, a positive and a negative, a positive and a negative. That concludes the video on delocalization.